Here we are at part 2 of the Module 6 chapter review, and our next section is using the distributive property to factor, and we've always called that factoring out a GCF. So you're going to look at the biggest thing that's common to both terms in the binomial. So for number 1, we would factor out a 7, and 7x divided by 7 would be x, and 49 divided by 7 would be 7. So here, number 4, the biggest thing that goes into 81R and 48RT, well, I might have a little trouble with those numbers, and so I might do a prime factorization. 81 is 9 times 9, and each one of those 9s is a 3. So 81 is actually 3 to the 4th power, and then there's an R, 48RT. So when I prime factor, if I do a factor tree on 48, it's 6 times 8, and then 6 is 2 times 3, and 8 is 2 times 2 times 2, and there's an RT. So this is sort of the long way, but by doing this, I can see that the only number that they have in common is a 3. And then the variables, they have an R. So I would get 3R as my GCF. And then 81R divided by 3R is 27. And 48RT divided by 3R is 16T. And then let's go on to number 7 here. As I inspect my 4 terms, I see that all 4 of them don't have anything in common, so then I might try to use a grouping strategy. So let's see here. I see that, and I use this strategy pretty much whenever I have 4 terms, and so I'm going to group the first 2 and I'm going to group the last 2. So the first 2 have an x in common. So if I factor out an x, I get x plus 3. And the next 2 don't have anything, so I say they just have a GCF of 1, but then what's left over, here's where the magic happens. When I have a match in my parentheses, I can bring that down, and then I can create another binomial out of what's left over. So this one actually factors into a product of binomials. And numbers 8 and 9 are going to follow that same type example. In the next section, we're factoring quadratic trinomials, and they don't have a leading coefficient. So remember, we make our t-chart, and we look at C. We want 2 things that multiply to equal C that add to equal B. So I'm looking for 2 things that multiply to equal 12 that add to equal 8, and so I might make a wrong guess at first. I might say, oh, well, 3 times 4 equals 12, but they only add up to 7, so that's not going to be the correct combination for me. And then eventually I find that 2 times 6 multiplies to equal 12, adds to equal 8, and so once I've found my combination, I can simply rewrite my polynomial as a product of 2 binomials using the positive 2 and the positive 6 in my binomials. And so that's going to change a little bit when your signs are different. So for example, in number 3, I want 2 things that multiply to equal negative 18. And so the only way to get a negative 18 is to have 1 positive and 1 negative, and then I want 2 things that add to equal 3. And that's going to be a positive 3. So there's several combinations of things that multiply to be 18. I could do negative 2 times 9, but when I add those I get 7. And then let me try negative 3 times 6. And sure enough, those add up to be 3. So I've got my n minus 3 and plus 6. And so sometimes we might have to, like in number 8, we might have to rearrange the order. We need to put things in standard form before we can decide what A, B, and C are. And so now I see that I need 2 things that multiply to be negative 4. that add to equal -3. So that'll be -4 times 1, and that adds up to the right number, so I can rewrite my polynomial as a product of binomials, and those are equivalent. So what happens when we have a leading coefficient? So these problems have an a value in the front, and occasionally we'll need to factor something out first or not. But whenever we have an a value in the front, that means we need to use the AC method. So I'm going to start with number 3, and I'm going to see that I have a 2 in front, so I'm going to do a times c, or 2 times 15. I'm going to make my chart, and so I need two things that multiply to equal 30 that add up to be -11. So as I'm multiplying to get 30 and I want to add up to be a negative, I'm going to try 3 times 10, and oops, that adds up to be a positive number. So next time around I'm going to put two negative numbers. So what else multiplies to be 30 that could add to be -11? So now I'm going to try 2 and 15, and I'm going to do -2 and -15. And I get a -17. So I think there's really just a few more combinations of numbers that equal 30, -5 times -6, and that's going to add up to be the right value for me. So once I have these numbers, though, I'm not finished. I have to rewrite my polynomial and split the b term. So I'm going to take 2t squared minus 5t minus 6t plus 15. And I'm going to, now that I have 4 terms, I'm going to use that GCF strategy, or the grouping strategy. And I want to be really mindful of what is my GCF of each pair, and I also want to be mindful of this minus sign here. It's going to come down as part of my second GCF. So of the first 2 terms, the only thing that goes in to both is a t. So that leaves me with 2t minus 5. And then in my next 2 terms, I see that a 3 goes in, and that minus sign is just going to come right down. So I'm actually factoring out a -3 out of both. And that way I can do minus 6t divided by minus 3. I get a positive 2t. And remember, I'm going for a match here, so that kind of goes with what I want. And then positive 15 divided by -3 is going to give me a -5. So I have that match inside the parentheses, so that's going to come down as part of my solution, and then I'm going to build my other binomial, and I'm done. So let's take a look at number 7. Number 7, when I do 3 times 63, I get a really big number. I get, 3 times 63, 189, and that's just a big number, and so I get a little worried, and I want to look for a GCF there so that I can maybe make my numbers smaller. So if I can pull a 3 out of each term, I can rewrite my quadratic trinomial as a squared plus 10a plus 21. And then I don't have a leading coefficient anymore. It's been factored out. So now I can use just a regular factoring method where I want two things that multiply to equal c that add up to be b. So 3 times 7 is 21, and that adds up to 10. So here I go. I've got 3 times, not a squared, just a plus 3 and a plus 7. So that doesn't always happen. Sometimes, like in number 8, if I do 10 times -15, I get -150. And there's nothing that goes into all 3. So I need some things that multiply to be -150 that add to be -19. So I'm going to need one positive and one negative. So I start looking for what goes into -150. And I could do, like, I know 10 goes in, 10 times -15, but when I add those together I just get -5. And I could do 3 times 50, and that's going to be negative 47. So my answer lies somewhere in between there, and I am not really sure what it is. So maybe what else goes into 150? Well, I know 25 goes in, because if I have $1.50, I have 6 quarters. So 6 times 25, and I'll make the 25 negative, and 6 plus negative 25, there we go. So I'm going to go 10w squared plus 6w minus 25w minus 15, and then I'm going to do some GCF after I group. So between 10w and 6w, that's a 2w, leaving us with 5w plus 3. And then out of 25w and 15, a 5 goes in, and I bring down the minus sign. And so that gives me 5w plus 3. So there I've got a match inside my parentheses. And we're done. So factoring differences of squares,